In this video, we will learn about Venn diagram. In a Venn diagram, we use polygons to represent sets and their relationships. The universal set is represented using the largest rectangle. In this Venn diagram, the large rectangle is the universal set. The red circle represents the set A, the purple circle represents set B, and the yellow circle represents set C. So to represent a set inside the universal set, you have to draw a polygon, usually circle, and then write the name of the set beside it. Let's say we are given this Venn diagram. Let's write the elements of each set. The elements of set A are all the numbers within the red circle. So we have 1, 2, 3, 4, 5. Okay, therefore set A has the elements 1, 2, 3, 4, 5. How about set B? Inside the purple circle, we have 3, 4, 5, 6, 7. So these are the elements of set B. How about the set C? Within the yellow circle, we have the numbers 5, 6, 7, 8, 9. So these are the elements of set C. How about the elements of the universal set? We know that the universal set is the totality of all sets or elements involved in the problem. So we have to consider all the elements, rather all the numbers written inside the universal set, even these three numbers that are outside the sets A, B, and C. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the elements of the universal set are the numbers from 1 to 12. Now let's say we are given a set A with elements 1, 2, 3, 4, 5, a set B with elements 4, 5, 6, a set C with elements 5, 6, 7, 8, and the universal set whose elements are the numbers from 1 to 10. So how do we draw a Venn diagram that represents all the sets and their relationships? First, we draw a large rectangle that is to represent the universal set. Next, we draw a red circle to represent set A. Then we draw a purple circle to represent set B. Next, we draw a yellow circle to represent set C. Now, the simplest technique in populating the Venn diagram with the elements is to first consider the common element or elements of the three sets. So, the common elements or the intersection of the three sets, of course, is represented by this area. Okay, if we look at the three sets, A, B, and C, the only common element is the number 5. So we write 5 in that area. Next, we have to consider the common elements of sets A and B. Okay, we have here 4, 5, and on B we also have 4, 5. But 5 is already in the intersection of the three sets. So in this remaining portion of the intersection, we write 4. Next we consider the common elements of B and C, or the intersection of B and C. Do we have any? Yes, we have 5. Okay, but 5 and 6. Okay, but 5 is already in the intersection of the three sets. So on the remaining, or rather in the remaining portion of the intersection, we have 6. Now how about the intersection of A and C? Do we have any common element? Yes, and that is the number 5. Okay, and there we have the number 5 in the intersection of sets A and C. After we consider the intersections, we can now write the elements of the set A that are outside the intersection. So these are the these areas represent the intersection of A with the other sets. Okay, set A has the elements 1, 2, 3, 4, 5. But you already have 4, 5 in the intersection. So in this portion of set A, we have 1, 2, 3. Okay, how about set B? Sorry, in set B, we only have 4, 5, 6. But we already have 4, 5, 6 in the intersection, so we don't have to write anything in this portion of set B. Okay, next, how about set C? We have the elements 5, 6, 7, 8. But in the intersection, we already have 5, 6. Okay, so in this portion, in the remaining portion of set C, we have to write 7 and 8. Okay, the next question is, or rather the last, is have we considered all the elements of the universal set? In other words, do the three sets A, B, and C include all the elements of the universal set? So remember, in the universal set, we have the numbers from 1 to 10. Okay, let's check. 1, 2, 3, 4. We have here 4, 5, then 6, 7, and 8. Okay, so the three sets A, B, and C include only the numbers from 1 to 8. So outside these three sets, we still have 9 and 10. Let's say we are given this Venn diagram. By just looking at this Venn diagram, let's try to solve some operations or expressions. First, let's get the union of sets A and B. Sets A and B, so that is the union of set A and B, the combination of sets A and B. So we have to consider all the elements within the red circle and the purple circle. So we have to combine them. Okay, what do we have? 1, 2, 3, 4, 5. So the union of sets A and B is the set of 1, 2, 3, 4, 5. How about the intersection of sets B and C? The intersection we know is the common elements. Okay, so the intersection of set B and C is enclosed by the yellow circle and the purple circle. Inside that area, we only have 4 and 5. So the intersection is the set of 4 and 5. Next, let's say we have to get the intersection of the three sets. Okay, of course, the intersection of the three sets is enclosed by the yellow circle, the purple circle, and the red circle, and we only have 4 in that area. Lastly, how do we get the complement of set C? Set C is the yellow circle. So the complement of set C consists of all the elements or all the numbers inside the universal set but outside the set C, because the complement of set C do not belong to set C. So what do we have? 1, 2, 3, they are outside set C. But 4, 5, 6, okay, they are not included in the complement because they belong to set C. Then we have 7 and 8. Therefore, the complement of set C is the set of 1, 2, 3, 7, 8. Okay, finally, let's consider a word problem that we can solve using a Venn diagram. The problem says, a survey in a class of 50 students finds that 30 students like science, 25 like English, and 20 students like math. While 5 students like the three subjects, 15 students like science and English, 12 students like English and math. How many students do not like any of the three subjects? So as I've said, we can solve this problem using a Venn diagram. So first, we have to draw the Venn diagram. How do we do that? First, we draw a rectangle to represent the universal set. Then we draw a large red circle to represent the set of students who like science. Then we have a medium yellow circle to represent the students who like English, E for English. Then we have a small purple circle to represent the students who like math, so M for math. So let's populate this Venn diagram with the elements. Okay, first let's consider the intersections, remember? especially the intersection of the three sets. Okay, in here we have 5 students like the 3 subjects. So in this intersection of the 3 sets, we have 5 students. Okay, next, how about the intersection of set of science and English? Science and English. Okay, we have here 15 students like science and English. 15. So in this area enclosed by the yellow circle and purple circle, we should have 15. But we already have here 5. So in the remaining portion of the intersection, we have to have 10. Because 10 plus 5 is 15. Next, how about the intersection of English and math? Do we have that? Yes. 12 students like English and math. Okay, so in this intersection of the purple circle and the yellow circle, we have to have 12 students. But we already have 5 here. So in the remaining portion of the intersection, we have to have 7. Okay, next. How about the intersection of math and science? Do we have any statement about that? No. Okay, so next, let's populate the set A with elements. Okay, set S rather instead of set A. Okay, so according to this part, 30 students like science. So within the red circle, we have to have 30 students. But in the intersection, we already have 10 plus 5, 15. So in the remaining portion of set S, we have to have 15 students because 15 plus 10 plus 5 is 30. Okay, next, how about this set of of students who like English? 25 students like English. So within the within the yellow circle, we have to have 25. But in the intersections, we already have 10 plus 5, that's 15, plus 7, that's 22. So in the remaining portion of the set E, we have to have 3 because 22 plus 3 is 25. Okay, next, how about the set M? Okay, we have here 20 students like math. But in the intersection, we already have 5 and 7, that's 12. So in the remaining portion of set M, we have to have 8 because 12, because 12 plus 8 is 20. Okay, so let's ignore the 2 for now. Okay, so the question is, how many students are represented by the sets science, English, and math? So we only have to add up the numbers inside the 3 sets. So we have 15 plus 10, that's 25, plus 5, that's 30. These two add up to 10, so 30 plus 10, 40, plus 8, 48. But there are 50 students in the class. By the way, the class is the universal set. So inside the universal set, we have to have a total of 50 students. But inside the 3 sets, we only have 48. So outside those sets, we have to have 2 students. Therefore, how many students do not like any of the 3 subjects? There are 2 students. If you have any question, please leave a message.